Good evening, dear friends. In this particular video, I will deliver the information pertaining to representation of functions on a computer pertaining to the course Computational Fluid Dynamics. Students, you are all aware that computational fluid dynamics is one of the dominating thermal engineering subjects wherein you can understand the numerical aspects very meticulously. In the earlier video, I could give an epigrammatic overview pertaining to computational fluid dynamics, the different modules that configure this amazing course. But in this particular video, let me deliver the information pertaining to the specific module representation of functions on a computer. Okay, let me give an introductory remark pertaining to this module. You all know that while operating a system or a computer, you will be aware of various functions. I think I need not have to emphasize any information about the various functional keys you use in a laptop or on a desktop or in a mobile phone. Very similar to that, in computational fluid dynamics CFD, we have a particular module representation of functions on a computer. Okay, let me tell what are all the various items we need to study in this, which are all the topical topics we need to cover in this module. Initially, one should be aware of the need of representation of functions. Where is the need for representing or accommodating functions in a computer? Later on, we will be coming across three specific mathematical functions, namely box, hat, and har functions. That is very important in the assessment or examination point of view. This is a very commonly asked question on that. Later on, there is a specific topic called machine epsilon. That is also very important. We shall know what exactly is that. Later on, we need to be aware of something called representation of sin x function, trigonometric function using hat function, specifically learning analyzing high and low frequencies. These are all the topics what we need to come across in this particular module. Fine, let me give a synoptic introduction or summarization pertaining to this particular module. As I said, where is the need for representation of functions on a computer? Why do we need it? Friends, very simple. Why do we have a particular name for an individual? Why? Because for easy identification. Analogously, why there is a need for representing functions on a computer? For easy and very simple identification. Alright, let me take an idea here. Hope you might have come across a concept in learning computers, data structures. You all know that on a computer, knowing about data is very important. Okay. Very similarly, pertaining to the study of data, we have data analysis or data formatting or data structures. Okay. Yes, I think now you are getting the idea. Very similarly, in the case of mathematics, I gave an analogy pertaining to computer science. Very similarly, in the case of learning arithmetics in mathematics, Have you not come across representation of numbers? Yes, you already come across something called binary system. Okay, binary numbers, bits, they are very important. Okay, don't you really think while learning computer programming or the concepts of computer, have you not come across bit and bytes? Yes, very similarly, the concept is applicable to representation of functions on a computer. Okay, I think slowly you are getting the link. First, when we get the idea about representation of numbers, then we will get why there is a need for representation of functions on a computer. Okay, first we should be aware of the need. Alright, slowly let me take up the idea. Friends, let me tell you this particular module of computational fluid dynamics, that is representation of functions on a computer, it is purely pertaining to mathematics. Okay, hope the students who studied primary schooling, they have come across arithmetic. Okay, in learning arithmetic, they have come across binary number system, floating point concept, the same ideas here also it will be portrayed. So you don't find any difficulty in learning the idea. Okay, I think you have got the introduction pertaining to the need of representation of functions on a computer. Then immediately you will ask me why? Why do we need to represent functions on a computer? Friends, for three. For three basic reasons we need it. What are those? Number one is to achieve accuracy. Second one, to accomplish efficiency. Number three, very important, to maintain computational speed. Okay? In learning computational fluid dynamics, please bear in mind speed and time are very important. Okay, while learning theory of relativity, speed will not come to picture, space will be picturized, space and time. In the beginning modules of computational fluid dynamics, you might have come across space and time, but here it is speed and time. Okay, that is why we need to emphasize on representation of functions on a computer. Okay, what is the next exercise we need to exercise? I told that one should be well acquainted with three functions, namely box, hat and har functions. Okay, very simple way. Okay, let me take up so that a simple person or a layman will be in a position to understand. What is this box function? Directly, let me not emphasize in the language of computational fluid dynamics. These name functions, they are related to mathematics, core mathematics. Okay, you know that when mathematics you come across differentiation, integration are emphasized. Here also it will be picturized. Okay, so what is that box function? Box function is basically an integer function. Have you not used integers while solving problems on arithmetic? Yes, it is a typical box wherein we depict various nodes. Okay, I think you have come across a name grid. In a particular grid, we depict many nodes. Okay, very similar to that. In learning a representation of functions on a computer, the first function is what? Box function. Okay. Yes. What is the next one? It is hat function. Don't you really think I'm giving an analogy during sultry weather or during rainy season, people prefer hats, variety of hats, or they may use a stylish umbrella. Why? What is the reason? Why? To safeguard us. That is the only reason. Here also, this box and hat function, they are the building blocks. In order to know about the representation of functions on a computer pertaining to CFD, box and hat functions, they play a significant role. Okay, I told about box function. What is this hat function? Friends, this is once again applicable to mathematics. Hat function, it is typically a triangular function. Okay, I think when you come across the concepts in physics, have you not studied sinusoidal waveform? Very similar to graph theory. The students of computer science, they come across graph theory. Okay, in learning graph theory, there's a triangular function, the box representation, then the functions in the shape of square, it will be emphasized. Okay, similarly, in the module of representation of functions on a computer, we come across what? Hat function. Please bear in mind, hat function is a triangular function. Fine. It can represent any concept in the subject CFD. Without the application of mathematics, particularly arithmetics in CFD, this particular module will not be emphasized. Okay, so this is all about box and hat functions. Okay, what is the next idea? Friends, I am going in an order so that any student will be in a position to comprehend the topic very meticulously. Fine. What is the next idea? Representation of sin x function using hat function. I gave an analogy or an example just now. While learning physics, have you not come across sinusoidal waveform? Even in any subject, whether it is physics, mathematics, astronomy, or any other technical subject, very normally which trigonometric function will be highlighted? Sine. Okay. Here I am giving an analogy with respect to sinusoidal waveform. When you write a sine wave, in the case of physics or learning electronic subject, mainly signal processing, have you not written sinusoidal waveform? Yes. Other than physics, in the subject or in the course signal processing, you have come across. Okay. The three terms associated with the course signal processing are aliasing, high frequency and low frequency. Okay. What is that aliasing? Aliasing meaning what? It may lead to misconception resulting in an error. Okay. You cannot expect always the propagation of signal to happen very significantly. There may be some sort of distortion, or the individual may have some sort of misconception. Okay, the misconception or distortion will result in what? The failure in the propagation of signal. This will cause what? Error. Very important. Okay, in this course we discuss various errors: round off error, truncation error, human error. Okay, very analogously in the subject measurements we have studied error. Here also it will be emphasized. So friends, this is the next idea what you need to come across: representation of sine function using a hat function by learning what? Aliasing, high and low frequency. Remember, this is all relating what? Signal processing in the course electronics and communication. Okay, all right. Okay, slowly you are getting the idea. Initially you could gain why there is a need for representation of functions on a computer. Next you could get information about box and hat function. What is the next idea? You should come across something called Haar function. What is this Haar function? Box, okay. Representation of nodes in a grid, typically resembling a box. Okay, square by nature. Next, you came across hat function. It is a triangular function. What is this Haar function? Friends, you might have come across something called Haar wavelets. What are these wavelets? When we take up the term wavelet, I think you may remember some course in computer science or electronics or electrical and electronics. Okay, friends, there was a mathematician from Hungary, University of Göttingen, Alfred Herr, in 1909, he was responsible for identifying the functions which can be represented in the form of square. Okay, we came across triangular function, that is hat function. How hat had the ability to protect a person, very similarly hat function can protect any sort of dysfunctionality in the case of computers. Okay, very similar to that, we have square wavelet or square waveform system, that is called Haar function, named after Alfred Haar. Okay, can you please link this hat function and Haar function? One is the triangular function, Haar function is the square function. Okay, both can form orthogonality. Both belong to the class of orthogonality. Okay, but remember, triangular function is what? It is box function. What is this Haar function? Haar wavelet is very important. Okay, Haar function basically signify the square waveform. When you just remember Laplace transformation, you can link that course with control engineering. Okay, when you take up any course like control engineering in systems, one can clearly represent the waveform in the form of triangles or square. Okay, the similar analogy what you can get in computational fluid dynamics also. Fine. All right. We are getting many ideas in the representation of functions on a computer. So box, hat and Haar, H-A-A-R, named after Alfred Haar, a professor from Hungary, University of Göttingen. Okay, any other topic left in the study of representation of functions on a computer? Friends, there is a specific concept called machine epsilon. Okay, when you start with the word machine, for the students of mechanical engineering, they remember machine tools. But if a student belonging to the discipline of computer science and engineering, they can revive about machine learning. But you belonging to the students of computational fluid dynamics, machine epsilon. What is this machine epsilon? In the examination, you may expect an explanatory note on this particular topic. Machine epsilon. Okay, let me split the idea. When you just use the word machine, to which other word it is connected with, it is programming. Okay, when you are a student of computer science and engineering, it is basically what? Machine learning or programming. But here we are not dealing with any programming, we are dealing with mathematics. Okay, we will use a specific symbol epsilon. Why is that important? Let me tell you. What is this machine epsilon? Friends, while learning computer science or a computer course or mathematics, have you not come across something called rounding off error or round off error? Yes, this is regarded as a global error. When you learn a specific concept in arithmetic, that is floating point data type, in a computer language also it will appear, you will just come across the words significand, exponent, mantissa, radix, magnitude. Okay, I hope you are remembering the class of primary standards. You might have come across these terms. Okay, even the concept machine epsilon deal with that. So in a line, how can we define machine epsilon? Machine epsilon gives an upper bound. An upper bound for what? Relative error due to rounding pertaining to arithmetic concepts. What is this? I could not get the idea about that. You may ask. No problem. Friends, I told about floating point data type. When you represent numbers in a floating point data type, normally you come across what? You will encumber with round off errors. That rounding of errors may be relative by nature. Okay. So depending on that, we will give an upper bound for that. Okay. Therefore, what is the idea there? The difference between number 1 and the next immediate number, that is called what? Machine epsilon. Mathematically, when we write any sort of expression using this topic, it is represented by epsilon. Okay. So this is basically an upper bound for what? Relative error based on rounding pertaining to the concept floating point data type in arithmetic. Okay. So please remember, this particular term was used in 1900 by an American mathematician and a computer engineer, Weldon Demel. James Weldon Demel, he was responsible for exclusively and extensively use machine epsilon. Okay, so bear in mind, in this particular module, this has stronger emphasis. Okay, almost many of the topics we have covered in this particular module: box, hat and hour functions, representation of sine function for learning aliasing high and low frequency. Any other topic left? Just now we have come across machine epsilon. Friends, when we need to take up any problem pertaining to the representation of functions for the undergraduate level, the comprehension about illustrative problems in CFD may not be of greater importance, but for learning advanced level of computational fluid dynamics, numerical problems play a dominating role. So, what is the link I am giving? Friends, in learning representation of functions on a computer mathematically, please be well acquainted with Taylor series. Any problem will involve with derivatives. So you should have the exposure in writing Taylor's expansion very eloquently. Okay. So this is all the epigrammatic overview of representation of functions on a computer. Okay. I think any student will be in a position to understand what are all the things I have strongly accentuated. Okay. Let me quickly run through so that you can get the summary of this. Initially, what are all the items we need to be aware of? What are all the topics? Remember, this video I am mainly concentrating on representation of functions on a computer. Okay. So, what is the first one? One should be aware of the need. Why we need to learn. Okay. The second topic is what? You should be well acquainted with the two popular terms. One is box function, the other one is hat function. Okay. What is the next topic? Representation of sine function using hat function. Please bear in mind, we learn three ideas pertaining to signal processing, aliasing, high and low frequency. Okay. This is very, very particular with emphasizing the waveforms. Okay. Okay. I told about hat function. What is that hat function? You remember that for any person or a layman we will be using hat for the sake of protection. So which function is very significant in this module? That is hat function. That is what? It is a triangular function. It is like a cap. Okay. What is the other function we have come across? It is Haar function. HAAR, named after Alfred Haar in 1909. This is very particularly square waveform. Okay, this box, hat, and Haar functions they use in subjects like mathematics, finite element methods, and computer science. Okay, so you should be aware of the application areas also. Later on, we came across a very unique concept called machine epsilon. Okay, machine epsilon is very important. I told that this is very important in the representation of numbers based on floating point data type in arithmetic. Okay, lastly, when you need to solve any problem on this particular module, you should have the talent in writing Taylor series very proficiently. Okay, this is all the summary of this particular module. Hope you have got the information pertaining to this. For more detail, okay, other than listening to this video, you find n number of videos pertaining to computational fluid dynamics. One relevant material to study this particular module, okay, that is representation of functions on a computer. You can refer to a book authored by Professor M. Krishna. He has authored a book, Elements of Computational Fluid Dynamics. He is basically a professor at IIT Madras, Department of Mechanical Engineering. Even you can find very good videos of him, particularly on this particular module. Okay, okay, thank you very much. I think this epigrammatic video may be useful. Thank you very much for the opportunity. Good luck.